Regular expressions are a very complex subject and not one that I can comprehensively cover in a couple of movies in this chapter. I do feel, however, that it is important that I introduce them early on because they are so powerful and flexible and allow us to express a pattern in a very precise and a very concise way. What a regular expression does, essentially, is like a sophisticated version of what the like operator does. A much more sophisticated version, I should say, because it combines all kinds of logical operators and what have you within one simple pattern. It follows its own particular rules of syntax, which are completely different from the SQL rules of syntax. Here's a simple example of a regular expression. In this regular expression, we're testing for the letter E, and that could come with anywhere within the string. Because the letter E is contained within hello, that evaluates true. If we look for the letters H-E-L-L, that's also contained within hello, so that evaluates true as well. Now, let's look at an example of a way in which regular expressions are more complicated than the simple like operator. This straight up and down vertical line symbol, in this case standing between the letter H and the letter L, is essentially saying look for either the letter H or the letter L within the string. And because both of them are contained within there, this evaluates true. If we look for H or B, that would also evaluate true. However, if we look for G or B, because neither G or B are contained within the string, this regular expression would evaluate false. So that's one thing that we can do. We can use whole words as well. We can look at hello or goodbye. That would evaluate true. So we can use the vertical line as a very basic way of splitting up our regular expression. We can also specify that we want a certain part or a certain pattern to come right at the beginning of our string by using this particular operator here. And that's located on the 6th key on my keyboard. And if we search for that, we get a false response. That's because the letter E, although it's within the string hello, is not right at the beginning. Right at the beginning is the letter H. So that's what we need to use if we're going to get a true Boolean response from that. Similarly, if we want to find a letter or set of letters that come at the end, in this case O, we use a $ after the letter. That gives us a true response. If we put those two together, the H at the beginning and the O at the end, we might expect that to evaluate true as well. However, what is actually being asked here of the irregular expression engine is that it's checking for the pattern HO, which comes both at the beginning and at the end. So by using both of those particular symbols, the beginning and ending symbols, we are effectively locking the regular expression to both sides of the string that we're searching for and saying this is all that you can find, the letter H and the letter O. And because there are several letters in between there, we get a false response from that particular regular expression match, or should I say regular expression mismatch. In order to correct that, we'd have to put in the missing letters. So that's the most rigid way that we can use a regular expression, and that's effectively not even using it like a like, that's using it like an equality operator. However, we can be a lot more subtle with our regular expressions than that. For instance, instead of using the literal letters that are contained within the string, we can use dots or full stops. which each of them stand for one single character. So this matches H followed by 3 characters of any kind followed by O. And that evaluates true. It would also evaluate true if we put any 3 letters in between H and O. However, it would not evaluate true if we then put in a lot of letters between H and O. This evaluates to false. If we wanted that to evaluate true, there is something we can do. We can use a plus. And what the plus does is, it's not a symbol of its own. If we wanted to search for a plus, we'd have to escape it using a backslash, as we could for any of these characters. For instance, we could escape the $sign and then we'd be searching for a literal $sign. However, what the plus does when we haven't escaped it is it tells MySQL that it's looking for more than one of the immediately preceding character, which in this case is a wildcard, is a dot. So it's looking for more than one of any character. So H at the beginning, O at the end, and at least one character, but as many as it can take in the middle. So that returns true. We could also try and match S's. H followed by 1 S, or 3 S's, or 100 S's. That would return false. However, if we replaced all these letters here with S's, then that particular regular expression would be true. So we can see regular expressions allow us to express in a very complicated things in a very short, concise way. Another way that we can be quite precise here is to specify that we don't just want any number of S's. We want, for instance, 3 S's, which will return false because we have a lot more than 3 S's there. Of course, if we do reduce it to 3 S's, it will return true. We can also specify ranges within these curly brackets, and the curly brackets here are what is specifying that we want 3 S's. So there's a number within curly brackets, and that will always refer to the letter or character or symbol, whatever it immediately follows. So in this case it's S. We can specify 3, or we can specify a range such as between 3 and 10. So that will return true, but so will 7 S's. But for instance, a whole load of S's, because that's more than 10, will return false. As we can see, these regular expressions allow us to express very complex things within a very concise framework. In our next movie, we're going to get deeper into the way regular expressions work.